Watch and listen to the video for today's lesson. Write what I write on your notes page. You will have an assignment for a grade today. Pause the video if you need more time to copy vocabulary or work each question in the notes. Use the notes to help you complete your daily assignment. Please have excellent behavior today. Topic 4.5, special segments of triangles. You're going to copy the red text into your notes and write what I write. A segment joining the midpoints of two sides of a triangle is called a midsegment. So when we have two sides of a triangle, I'm looking at this left side, we are going to cut it in the middle, and we can see from our markings, this marking is the same as this one. They both have one little mark. That's showing that they are the same. So we have this mark at point D right in the middle. Then when we go to the other side of the triangle, segment CB, we're going to cut that one in the middle also. So if you'll notice, we have more markings. This time it looks like two little marks, and two little marks matches. That means those are the same. So point E is right in the middle. The mid segment joins those two middles of the sides. So your mid segment is going to be from D to E. Does this go through a vertex? No. Does this include midpoints? Yes, we are on the midpoint of both sides. Does this form a right triangle? No. Altitude is next. An altitude is a segment from any vertex of the triangle, and then this symbol right here means perpendicular to the opposite side. So we're going to start off at a vertex. In this case, I'm looking at A. So we're starting off at A, and we are going to go perpendicular to the opposite side. So right across from A is the side BC. So I am going to drop a line that makes a right angle. So this right here is going to be my altitude, and that is from A to D. So from A to D, segment A to D is my altitude. Does it go through a vertex? Yes, at point A. Does it deal with midpoints? And we can see from this, when we look at the bottom, those sides are not equal, so no. Does it form a right angle? Yes. That is what happens whenever we have perpendicular. Those right angles are formed. Angle bisector is next. For angle bisector, a ray or segment from a vertex to the opposite side of the triangle, dividing the angle in half. So this right here, this dashed line right here, segment, is our angle bisector. It's cutting angle B in half, and we can see these little markings right here. The one little mark matches on the left and the right. That means that those sides are the same. So we cut that whole angle B into two equal pieces. Is that going through a vertex? Yes, we're starting at B, and it even says in the definition vertex. Are we dealing with midpoints? So when I look at this bottom line right here, is that angle bisector cutting that in half? And the answer is no. Does it form a right angle? It can, but it doesn't necessarily mean that it will. So the answer is going to be no. And that one was from B to X. That is our angle bisector. A perpendicular bisector, the definition says a ray or segment, and this symbol means perpendicular, to a triangle's side, dividing it in half. So we have a ray or a segment, perpendicular, and I can see that marking right here, that perpendicular, that right angle. And so what we're doing is we're cutting that side in half, and we can see those markings, the one little tick mark on both sides. That means that this side is the same as this side. And then we have to make our line perpendicular. So we have our side, and we have our perpendicular bisector right there. Our perpendicular bisector is this line right here. Is it going through a vertex? Not in this case. Midpoint. And the vertex, it doesn't ever really have to go through the vertex, but sometimes it might. Midpoint. Is it going through midpoint? Yes, because we are creating this left side and the right side are going to be the same because we are bisecting it, cutting it into two pieces. Is it forming a right angle? Yes, that word perpendicular is telling us that it is going to form right angles. And we can see the right angle marking. Median. A median is a segment joining any vertex of the triangle to the midpoint of the opposite side. So it's going to be from A to E, that segment from A to E is this right here. So we start out at the vertex, and it says midpoint of the opposite side. So the opposite side is all the way over here from B to C, and we are cutting that in half. It's the midpoint. Midpoint means the middle. So that's where E is in the middle. And we can see those markings. We have two little marks on the left from B to E. That means that that side is the same as from E to C because those markings match. So this distance from B to E is the same as from E to C. Is it going through a vertex? Yes, the definition says vertex. Is it dealing with midpoints? Yes, and the definition actually says midpoint. Is it forming a right angle? No, it does not have to form a right angle, and in this case you can see that it doesn't. And then the last vocabulary word is centroid. The centroid is the intersection of the three medians of a triangle. And we can see from all the markings, we have one marking down here on the left bottom. That means that that's going to be the same as the right bottom. So this piece on the left is the same as this piece on the right, and that would be the midpoint. When we go along the other side, we see markings that are the same again, which means that from there to there is the same distance as from there to there. Same markings mean the same distance. And on this left side, we see three little marks and three little marks. So it's different than the other sides, but I know that from here to here is the same as there to there. From the A to the center, and then from the center back to B are the same. Example number 1 says to draw a triangle with an altitude outside of the triangle. So in our note, the altitude picture that we were given looks kind of like this. So when we start off at this top vertex and we drop our altitude, altitude is like the height. So you're going straight down to the ground. So we are making that right angle with the opposite side. So this altitude is not outside of the triangle. So we're going to have to draw again. So whatever vertex we have is going to need to drop outside of the triangle. So our triangle maybe needs to be really slanted so that that altitude is outside of it. And we can see that 90-degree angle. And this is what it looks like. It's kind of weird because that right angle is not actually touching that opposite side, but that's what it would look like. Example 2, DB is an altitude of triangle ADC, and the measurement of angle DBC equals n squared plus 81 degrees. Find the value of n. So we're going to mark up our picture. When it says that BD is an altitude, that means that that's 90 degrees, and that's going to be important. It also tells us that the measurement of angle DBC is going to be this n squared plus 81. But we already know that it's 90 degrees because of that right angle. So what we can say is that it equals 90 degrees because they are the same. And so I'm going to rewrite that where I have space. 81 equals 90. And then we're going to solve our equation. You're going to drop your line down the equal sign. And we have our letters on one side, and we need to move our plain numbers, our constants, to the other side. So we're going to subtract 81. These cancel, and we have n squared equals 9. To undo a square, we are going to do the square root, and the square root and the square will go away, so n equals. And when we take the square root, we get a positive and a negative answer. So the answer is a positive and negative 3. Since we are dealing with a triangle, an answer of negative 3 does not make sense. So we are going to say n equals 3. We're going to skip example 3 for just a second, and we're going to move on to example 4. Example 4, we have TA is the median is the middle, of triangle RTE, and AE equals 3x minus 11, and AR equals x plus 5. We're going to find the lengths of AE, AR, and ER. So a median means the middle. So TA is cutting this side in half. So we have the top A to E is the same distance as A to R. So you're going to mark up your picture and you're going to show that. And then the next thing we have is that AE is 3x minus 11. So I'm going to write that down. 3x minus 11. And then I also have that AR is x plus 5. Now, from when we marked it up, we talked about how they were the same, and the same is equal. So we can say that 3x minus 11 is the same as or is equal to x plus 5. And then we're going to solve our equation. Drop your line down your equal sign. Remember, we're moving all the letters to one side, and then the plain numbers, the constants, to the other. So I'm going to subtract this x so that all of my x's are now on my left side. 3x's minus an x will be 2x. Minus 11 equals 5. And then I'm going to move all of my plain numbers to the other side of the equal sign to undo a minus 11. The opposite is adding 11. And we have 2x equals 5 plus 11 gives us 16. Our last step is going to be to isolate the variable, get the x alone. So we're going to undo by dividing. We're going to divide by 2 so that 2 divided by 2 is 1, and all I have left is my 1x. 16 divided by 2 is 8. So that means that x is 8, but we haven't answered the question. This question is asking us to find the distances. From A to E, we know that it's 3x minus 11. So 3x minus 11, we now know that x is 8. So in this spot right here, we're going to put an 8. 3 times 8, and then subtract 11. 3 times 8 is 24, minus 11 is going to give us 13. Now, because this A to E, or EA, right here, is the same as A to R, we should be able to do the same thing, and we should get the same answer of 13. So let's do x plus 5, and remember that x is 8. So we're going to plug in an 8. 8 plus 5 is 13. And did they match? Yes, they match. So that means AE is 13, AR, let's write that a little bit different. AE equals 13, AR equals 13, and then ER is all the way from one side down to the other. So if this piece is 13 and this piece is 13, together, 13 plus 13 is going to give us 26 all the way from E to R equals 26. And so those are your 3 answers for example 4, 13, 13, and 26. Now we're going to go back to example 3, and we're going to be doing some of the same steps that we did in example 4. This time we're not talking about the median, we're going to talk about a bisector. And again, bisect is just to cut it into 2 pieces. It says in triangle RTE, so that means RTE, so this triangle right here, TA bisects angle RTE. So that means that we take this angle right here and we are going to cut it in half. So our marking that we can do is that this angle is the same as this angle. And you can do the same markings to show that they are the same. It says RTA is 3y minus 4. 3y minus 4. And then it says ETA is going to be 4y minus 17. Find the measure of RTE. So we're going to find the big measure overall. And we know that each of these small angles are going to be the same. Now because they're the same means equal, we can say that 3y minus 4 is equal to 4y minus 17. You will need to have your diagram marked up so that you can see that the angles are the same. We're going to draw our line down our equal side, and now we're going to start solving. This is the way that most of you will have written it, so I'm going to solve it the way that I feel most of you would want to solve it. We're going to move our letters over to the same side, so now these cancel out. And if I have 3 y's and I take away 4 y's, I'm going to have a negative 1 y, and that's okay. Minus 4 equals a negative 17. Do not forget that negative sign. Don't let it get lost. Our letters are now on one side, and now we need to move our constants, our plain numbers, that minus 4 to the other side. The opposite of a minus 4 is a plus 4. So we have negative 1y. The 4's will cancel out. And if you need help with this piece, type it in on Desmos. Negative 17 plus 4 is going to be negative 13. Your last step is going to be to isolate your variable. So whatever is next to your variable, your letter, you're going to divide by that. So we want to divide by not just a 1, but a negative 1 on both sides, because negative divided by negative will be a positive. The 1's will divide out, and the negatives will also divide out. So we have a positive 1y. And then negative 13 divided by a negative 1. Again, if you need help, you can type that in on Desmos so that you can get your sign correct, is a positive 13. So that means the value of y is 13. but it's not asking for the value of y. It's asking us to find the measure of RTE. So again, we're looking for the measure of this whole angle. So we're going to plug in what we got. We're going to plug this 13 in to where the y's are. So we have 3 times 13, and then we're going to do minus 4. 3 times 13 minus 4, you can type that in on Desmos if you need to. You will get 35, so that means this angle is 35 degrees. Now, if this angle is 35, that means that the other one is 35 also because they match. So to check to see if I am right, we can again plug in 4 times 13 minus 17, and we can type that in on Desmos, and you can see that you will get 35, and that's good because they're supposed to be the same. And so that means that we have to add them together to find the big angle altogether. So 35 plus 35 is 70 degrees. So our final answer for this question is 70 degrees. RTE is 70 degrees. Example 5, find CD. CD is right here, and I am noticing that I have markings on this right side of my triangle, and those markings are the same. That means that from X to C is the same distance as C to Y. I see different markings on the bottom, and those different markings are the same as each other. And so that means that Z to D is the same distance because it's the same marking as D to Y. But these are different than what I have in red because they're different markings. Now what we have is a segment connecting the middle of one side to the middle of the other side. And so that means this is going to be mid-segment. When we want to write a rule, we can say parallel to another side of the triangle, and we can say that the longer side is 2 times the shorter side. So this side is double, 16 is double the mid-segment. So in order to find what the mid-segment is, we can cut it in half. So another way to think about that is the short side is half of the long side. So 16, and I'm going to write it like this, divided by 2 is going to be 8. So let's check out our rules. Let's see that. CD is 8. So if we look at this first rule that I wrote, the longer side is twice the shorter side. Is 16 twice 8? 8 times 2? Yes. And then the way that we figured out, knowing our other way to say it, short side is half of the long side, is 8, half of 16. Yes. So our answer for that one is 8. Example 6, using what we just talked about, we see again, we're looking for AC, and AC is parallel to TS. TS is special because the left side of the triangle, we can see that T is in the middle. On the right side of the triangle, we can see that S is in the middle. So that means this piece is called the mid-segment. And this is what we just talked about in example 5. So that means that this side right here and this side down here have that relationship. And the first thing that we wrote was that the longer side is twice or 2 times the shorter side. So if we have the shorter side, we have 4. Then we're going to do 2 times 4 to get 8. So in this case, the answer is going to be 8. The answer is not always going to be 8 when we do the mid-segment, but in these two examples, it just happens to be. And you can actually kind of take an unofficial measurement so that you can see from here to here this distance, and then you can compare it. So that would be like 4, and that would be 4 because this distance right here, and that would give you 8. Example 7 is another mid-segment example. And this one's going to be a little bit more difficult because we have expressions. We don't have just given numbers, constants. But I can see it's a mid-segment question because, again, one side of my triangle has the same markings. Well, that means Z is the middle. And I see markings that are the same on the other side of the triangle, which means that Y is in the middle. So if I have a segment connecting the midpoint of two sides, that is a mid-segment. So what we can remember is that we have two of these shorter sides. So we can write it 2 and then x plus 2 is equal to the long side, 3x minus 8. So another way to think about it would be to think about this is like an x plus 2 and this is like another x plus 2. And together, that is the 3x minus 8. Now, if you like the way that I wrote it in that circle, x plus 2, in this circle right here, you can do that. I chose to write it with distribution. So if you combine your like terms, x and x, you'll get the same thing that I get whenever I do 2 times x, 2x. If you combine your plain numbers here, 2 plus 2, you'll get the same thing that I get when I do my distribution, 4. And that equals 3x minus 8. And we're going to now solve. And again, I'm going to do this the way that I feel that most of you would do it. Y'all like to move your letters to the left. So I'm going to move my 3x's over to the left. And that's going to end up with a negative 1x plus 4 equals a negative 8. Then I'm going to move my constants, my plain numbers, get rid of plus 4 with the opposite, minus 4, on both sides of that equal sign. So I have negative 1x. And then if you need help with this, you can type it in on Desmos. Because they are the same signs and we are combining, that stays a negative 12. Our last step is going to be to isolate the variable, so we divide by whatever is next to the variable, which will be a negative 1. Negative divided by negative gives us a positive, so those negatives go away and I'm left with my 1x. A negative divided by a negative gives me a positive. If you need help with that, you are welcome to type that in on Desmos. And a negative divided by negative is positive 12 in this case. Now for this question, all I needed to do was solve for x, so my answer is x equals 12. You have to read the question to find out what you're looking for. If this question goes one more step and it wants to know what is the length of the mid-segment, you would have to plug in that 12. And I'm going to go ahead and do that, length of mid-segment. So that's like another question. The length of the mid-segment would be x, which is what we just found, 12, plus 2, and that would be 14. So that's the length of the mid-segment. We could also extend the question and ask what is the length of that side that's parallel to the mid-segment. And again, you would plug in your 12 in order to find that length. However, for this question, it just wanted to know x, so we could stop at 12. You are submitting your answers to the daily assignment on Schoology, and you are turning in your special segments worksheet because you must be showing your work for full credit. You are welcome to use the notes that we took together to help you with your daily assignment. You are going to keep the notes, but you will be turning in the assignment paper.